Hello, hello. We're going to do Chapter 11, Homework 12. So, this is about tangent lines, which is kind of different from inscribed angles. So it's good to kind of do two different things at once. So here I see an inscribed angle, but I'm looking, it looks like they want the measure of these sides. And the other weird thing is I don't really see a tangent line, so I want to talk about that. So notice it says determine if AB is a tangent. So we're supposed to imagine this line keeps on going, but they just wrote it on the paper to make it a little clearer. What if I just focused right here on this line segment inside the line? Is it tangent? Well, if it was tangent, then this would be a right angle. So we don't know if it's a right angle. I'm going to make a box and just put a question mark. I don't know if it's a right angle. But if it was a right angle, then this triangle, A, B, and they didn't name this, so we'll just call it C, so we can name it something. Then that triangle, if it is 90 degrees, then this would be, we'd have A squared plus B squared is C squared. So one side and the other side. So there's a little bit of a mystery here. We kind of have to know our vocab. The length from the center to an edge is called a radius. And the length of the center to the edge is also the radius. So they're telling us, without coming out and telling us, that the length of that side is 7 plus 7. And so it's really the diameter. The diameter here is 14. Okay. Now they said this length is 17 and a half. So now I can do a calculation here. I don't know if it is, but if it was 90, then 10.5 squared plus 14 squared would have to equal 17 squared. And again, just make sure you set it upright. The biggest number should be over here. That's our hypotenuse. Okay. So, but I don't even know. I'm not sure if this side plus this squared equals this side because I don't know if it's a right angle. But one way to tell is if the left side. So the word if means if this is tangent, then the left side of the equation, excuse me, couldn't see that. The left side of the equation should equal the right side of the equation. If it is, in fact, tangent, because if it's tangent, that would have to be 90. And if it's 90, A squared plus B squared has to be C squared. So let's do it. So that's just 10.5 times 10.5. And that's 14 times 14. And that's 17 and a half times 17 and a half. And this time I do get a calculator. There's some tricky calculating here too. Okay. 110.25. Does 110.25 plus 196 really equal, so I don't know if the left side equals the right side, 17.5 times 17.5, 306.25. So let's find out. Okay, so 110.25 plus 196. Ooh, cool. Yes. So I ended up getting the left side totally equal to the right side. So yes, it is a tangent line. Okay. Now, next question. It says find the segment length indicated. Okay. So in algebra, I usually like to just make X what I don't know. They just put the question mark here in the middle. So they want me to think about this, and they also want me to decide that I should probably already know that. So the definition of a radius is the middle to the edge. We already know that's 3.5, so from the middle to the edge would be 3.9. And now I have some information. And they say, assume the lines which appear to be tangent are in fact tangent. So here we go again. It looks like this path, right, would meet the circle at a single point. That would be a tangent line. So they want us to assume that this line here that looks tangent is in fact tangent. So what they really want me to assume is that there's a box there, that that is in fact a 90-degree angle. Okay, so it's kind of the opposite of the last question. So now I'm assuming, because they told me that that's a tangent, which means that's a box. Well, that means I can set up an equation to solve for x. So I'm just going to redraw my triangle here. Okay, so 3.9 is the length of one side. So 3.9 times 3.9 squared, or 3.9 times 3.9. Then this side's 8, okay. So that'd be 8 squared, or 8 times 8. And this last one, I gotta use segment addition, right? This one and that one together would equal 3.9 plus x. Okay, so this is 3.9 plus another x for the whole segment. And I gotta square it. So you're probably getting flashbacks. That looks like what some teachers call FOIL. I have to distribute the x to both terms. 3.9x plus x times x is x squared. And I also have to distribute this to both terms. So that would be 3.9 times 3.9. And this one would be 3.9 times x. Okay, so this side of my equation, I think we're used to looking at it this way. X squared plus, if I have two 3.9s, so I can combine those to get 18, carry the 1, 6, 7.8x plus 3.9 squared. Okay, so 0.9 squared, 15.21. Okay, now this side, oh, that's the number I just had there. 3.9 times 3.9, I already did that. Okay, so 3.9 times 3.9 is this 15.21 plus 8 times 8, which is 64. Okay, so now let's combine that. Okay. And it feels like an algebra classroom again. It's like, oh, wait a minute, am I taking the PERT again? I don't get it. So I'm going to have to get everything on one side and solve for x. So you're at home, you could probably use Desmos to double check your answer, or some type of fancy calculator. But what would you do on a test? Okay, so let's do here. Is 64. Well, I know in algebra, if it looks a little too sticky, you're going to use this formula. Negative b plus or minus b squared minus 4ac all over 2a. Okay, so what we call a is the number in front of x squared, and there isn't really one, so I guess that would just be a 1. And the number in front of b squared, excuse me, b is the number in front of x, and then c would be the number in front of c. Okay. So I like the easiest part is this 2a part. So 2 times 1 is just plain old 2. So I feel okay there. Negative b. So I got a negative 7.8 plus or minus, and I have to square that. Okay, so that'd be 60.84 minus 4ac. So minus 4, and then this, and then that. So minus and a minus is a positive. So minus 4, but minus a minus would be a positive. So 4, and then a, and then c. So 4 times 1 times another 64. Okay, so I've got to clean that up a little bit, but we'll keep going. So 60.84 plus 4 times 64, because that's 4ac, so 256. Okay, so I got negative 7.8 plus or minus the square root of 316.84 all over 2. Interesting. So when I took the square root of this, I got a much smaller number. I got negative 7.8 plus or minus, I got 17.8 over 2. So that's actually going to clean up pretty nicely. So in the numerator, I need to add those two numbers, negative 7.8 plus 17.8 over 2, and then I need to subtract. Okay, now I'm running out of space, so I guess I'm going to have to just scoot over here. Okay, so negative 7.8 plus 17.8 over 2, or negative 7.8 minus. Well, this is a length, so we're going to ignore the negative and just take our answer as the positive. So when I subtract these two, I get 10, and 10 divided by 2 is 5. Awesome. Check out the next video. I think I can actually fit in this one. Now these are quite a bit easier. These I call the party hat. So if I'm supposed to assume these are tangents, keep going on forever, that meets at a 90, that meets at a 90. That's the same line. And so we end up using some geometry theory of congruent triangles to figure out the left and the right have to be equal. So I'm just going to set up the algebraic equation. Cool. All right, now I got to get x by himself on one side. So 4x minus 3x is 1x. All right, and I still got to get that by itself. So I got to subtract 7 on both sides. I get x, and 16 minus 7 is 9. That one was a fast one. Thanks for joining us. Check out the next video for the back.